Hi dears, welcome to today's session on thermal properties of matter. As you know, this topic is very important topic for examinations like UPSC, NDA, Navy, Air Force, NTS examination like IIT, CUT, ANSET, state examination like MSET, EPSET. So, as we know that, what is matter? Matter is a phenomena which has mass, which occupy space. Matter has been classified into five different types, such as solid, liquid, gas, plasma, and Bose-Einstein condensed form. Like that, we have five different types of matters. Thermal means what? Heat. As we know, heat and temperature both are physical quantities which we deal in physics. What is physics? What is heat? It is a form of energy that gives sensation of hotness or coldness. For example, when you hold ice cube in your hand, you feel that one sense of cool. Similarly, when you hold a hot iron rod, you will get sense of hotness. So sense of hotness and coldness will give from heat concept. The SI unit of heat is joule and CGS unit of the heat is calorie. I will give some introduction topic. After that, I will go to the MCQs related to this topic. Please uh, be patient. Don't go for the MCQ. I need to provide some basic information related to topic. Then after we can go for the MCQs. Please be uh, patient. Please understand. Okay. Thank you. So here, unit of the heat is that is in SI method in system of international, that is joule. In lowest form like CGS, that's about the calorie. And what is the relation between calorie and joule? As we know, 1 calorie equal to 4.12, approximately 4.12 joules. 4.12 joule. So what is the exact definition of calorie? Heat required to increase temperature of 1 gram water by 1 degree Celsius. You have 1 gram object. I want to rise the temperature of 1 gram. This is 1 gram object we have. I want to rise its temperature into 1 degree Celsius. For that, what heat we supplied? The supplied heat we called as calorie. What we call calorie. Calorie. Heat will be measured by calorimeter. Calorimeter is a device which is used to measure heat. What is that one? Calorimeter. Okay. Then coming to next one, what is temperature? So as we know, temperature. So temperature is the degree of hotness or coldness. It's the degree of hotness or coldness, that is about temperature. It is the degree of hotness or coldness. Degree means what? That is about the range. So higher the temperature, greater will be the kinetic energy. You know very well. K is proportional to absolute temperature. If there is a more temperature, the molecule will have more kinetic energy. So how do you measure the temperature? Temperature is measured in Kelvin units. That will be measured in Kelvin unit. So temperature is a phenomena of heat flow from higher to lower. High to lower. That's about the temperature. How do you measure the temperature? By using of thermometers. By using of thermometer, we can measure the temperature. How many temperature scales we have? So there are, as of now, we have four different types of the temperature scale. One is about the Celsius, another one is Kelvin, Celsius. Okay, sorry. First one is about the Celsius, and here Celsius is introduced. Next one is about the Kelvin. Third one is about Fahrenheit. And the fourth one is Riemer. Not chemistry, it is Riemer scale. Sometimes it is called Riemer scale. So, that is about UMER. Okay, now what is Celsius scale? Celsius scale introduced by Andreas Celsius. And the scale will have thermometer is consist of mercury, as we know very well. So the scale will have one is lower point, one is upper point. Lower point and upper point. Lower, upper. Similarly, Kelvin also. This was introduced by Kelvin. Lower and upper. Like four different scales, they have four lower points, four upper points. First, let us see. I am going to consider. I am taking Celsius. Celsius lower point is what? So the Celsius lower fixed point, that is about 0 degree Celsius, and upper fixed point is 100. Okay, 0 degree to 100. The number of divisions in Celsius scale is about 100. Coming to Kelvin. In Kelvin, the lower fixed point is about 273.15. 273.15 Kelvin. And the upper one is plus 100, 373.15. 370.1. Okay. The number of divisions here 100. Here the number of divisions are 100. Coming to Fahrenheit. As we know, in the Fahrenheit, this is the Fahrenheit scale. The lower end point in the Fahrenheit, that is about 32 Fahrenheit degrees, and the upper one is about 212. That means the divisions of the Fahrenheit scale will be 100 degrees. Sorry, 180 divisions. Lower fixed point is 32. Upper fixed point is 212. And finally, Riemer. The lower fixed point is 0 and the upper fixed point is 100. The number of divisions from 0 to 100, that is about the 80. So finally, I can say that one Celsius scale introduced by Celsius. In the Celsius scale, the units we are taking as degrees Celsius. Celsius lower means lowest value in the Celsius scale, that is about the 0 degree Celsius. Upper fixed point is about the 100. From 0 to 100, the number of divisions in Celsius scale is 100 divisions. Coming to Kelvin, Lord Kelvin introduced Kelvin. Here, the lower fixed point in Kelvin is 273.15. Upper fixed point is 373.15 Kelvin. The number of divisions in the Kelvin is 100. Coming to third scale, that's about the Fahrenheit scale. Fahrenheit scale lower fixed point is 32 Fahrenheit degrees. and upper fixed point is 212. Between 32 to 112, there are 180 divisions are there in foreign scale. Coming to Riemann scale, the lower fixed point is 0, upper fixed point is about 80 degrees. Sorry, 80. So therefore, we can conclude that one. Four different scales have four different fixed points, upper and lower. Now how they are related to each other. Okay, that also we need to understand. So here we have a simple logic comparison. C0 Celsius scale, this is, and Celsius scale 0 reading 0, starting one is 0, lower fixed point, upper fixed point is 100 as well. The number of divisions how many? 180. Similarly, Fahrenheit scale, lower fixed point is how much? That is about 32. Am I right? And the number of divisions how many? 180. Kelvin, the lower fixed point is 273 by, okay, the number of divisions 273, and that is about the 100 division. Similar Riemann are 0 by 80. After simplification, you will get that one scaling relations between Fahrenheit, Celsius, and Kelvin, Riemann. So after this formula, this condition, we confirm that one at minus 40 degrees. Minus 40 degrees Celsius is equal to minus 40 Fahrenheit. Minus 40 Fahrenheit. That means when Celsius scale is equal to Fahrenheit scale, at minus 40 Celsius scale will be equal to Fahrenheit. Celsius scale and Fahrenheit will be equal to at minus 40. At minus 40. Similarly, our room temperature, healthiest body person temperature is 37 degrees Celsius, as we know very well, 98.6 according to Fahrenheit. Now, as per the Kelvin scale, what is the 37 degrees into Kelvin? So, the relation is Kelvin scale K equal to degree Celsius plus 273.15. So here I would like to say K equal to 0 degrees Celsius plus 273.15. Now I would like to take 37 degrees. So K equal to 37 plus 273. So this is about 310 Kelvin. 0.15. Okay. So that's about healthiest person's body temperature according to Kelvin is 310.15, 310.15 Kelvin. So like that we can able to convert the Celsius to Fahrenheit. Fahrenheit is converted to the what we call, that is about the Kelvin. Kelvin is converted to the Riemann scale. Like that we will convert the temperature scales into one form to another form. So here, based on the application of heat, metals will expand, and that we called as thermal expansion. What we call thermal expansion. See, after this we will start the MCQ series, don't worry. Thermal expansion. So thermal expansion we will observe along the length, along the area, along the volume. This is called as the linear expansion, areal expansion, volumetric expansion. The coefficient in linear expansion is defined by alpha. Coefficient of the areal expansion defined by the beta. Coefficient of the volume expansion is given by the gamma. Now alpha, beta, gammas are the coefficients of the linear expansion, areal expansion, volume expansion, and they are equal to alpha is 1, beta is 2, gamma is 3. Like that we have a relation. That's about the how we got the coefficients. So, and that is when we have the condition that we know very well. Linear expansion definition is what? That is, I can explain here. That is, change in length is proportional to original length. Change in length is proportional to applied temperature. So based on this one, we will get change in length is proportional to L and change of temperature. Small change in temperature, remove this proportional, then you will get alpha. Alpha equal to delta L by L delta T, and this is nothing but a linear expansion. Like that we have beta as well as gamma. Beta delta A by A into delta T. Similarly, volume, that is gamma delta V by what we call V into delta T. So like that we will express the coefficient of expansions like alpha, beta and gamma. So that we will, so this is all about the thermal expansion. And generally all metals on applying heat they are expand. Metals will be, sorry, metals upon heat they are expanding. Am I right? Even gases also will expand upon heating. But, okay, sorry, even liquids also expand when upon heating. Upon heating. But water, instead of expanding, it is shrinking, means not expanding, it is decreasing. All, see, metals, liquids, gases will expand on application of heat. When we input heat to the materials like solid, liquid and gas, they will be expand, means the size is increasing, like in lengthwise, area wise or volume wise. But water, if you consider, when we apply the heat to the water, this water, instead of increasing, it is volume is decreasing, sinking. The volume is shrink, and this behavior we called as, see, 0 to 4 degrees Celsius. At 4 degrees Celsius water will have maximum density and its size is reducing, so it is having minimum volume. At 4 degrees Celsius water will have maximum density, minimum value, and this typical behavior is called anomalous behavior. Only water exhibit anomalous behavior. Okay, so without wasting time then I would like to go for the, then I will, meanwhile I will express something. Okay, so first question that is in the series, which mode of heat transfer is shown in this setup, where heat flows from the hot end to the cold end through the direct particle contact without any movement of the material. See, heat transfer method is followed by three procedures. One is called convection, radiation and conduction. So convection is actual movement of the fluid. Fluid means what? Which, like gases and liquids are known as the fluid, which are having rolling property or flowing property. So here convection is nothing but actual movement of the fluid. Radiation is no contact is required. Conduction, there is a vibration of the particles, collisions. There is a vibration of particle collision. So from this one, you are able to see this is a candle With the help of the candle or gas burner or flame, we are heating this metal rod. When we place thermometer here, you are able to see heat is transmitted, the sense of heatness, we will temperature, these all things you are able to see here. This heat is transferred from the flame end to this knob end. So here this was happened because of direct contact, and this direct contact heat in solids will define as conduction. In conduction, heat is transferred through direct molecular collision or free electron movement. Free electrons were existed at the surface of the metal body. So that is, so conduction, the process of transmission of heat will followed by three methods, that is convection, radiation and conduction. Generally convection we observe in fluid. Radiation is transmitting of heat or temperature, so transmitting of heat without any contact, like sun radiations are falling on earth. Coming to second question, in the diagram below, heat is transferred by the actual movement of the fluid particles, forming current due to density differences. This process is called what? Here a question they given about the fluid. So that is A. Conduction, B. Convection, C. Radiation, D. Reflection. As just now we discussed here, fluid means that in 99.999 the answer is convection. That is about convection. Convection is a procedure where heat is transferred in fluids, that is about the convection. Convection occurs in liquids and gases, so they are known as the fluid. Hot fluid becomes less dense and rises, while cooler fluid sinks, creating current. See, you can see this is about the hot, this is about the cooler. So hot particle will float because they have they have less dense, so that they are floated, and cooler one they will be like thick, they will be form a thick layer that will be creating current. So that this procedure, it is we simply consider as convection, that is heat transfer in a fluids like gas and liquid. Coming to third question, the image illustrate electromagnetic waves transferring energy without any medium. So here how it transmitted, see you can see here convection liquids, in liquids here liquids we can able to see convection. So here this is about the convection procedure, this is conduction, direct contact. So some radiations are falling on the body without any medium help. This we call as conduction. This is we called as radiation. This we simply call radiation. So the answer is radiation. That is, radiations involve infrared or other electromagnetic waves like gamma rays, X rays, UV rays, visible rays, infrared, microwaves, radio waves. These are nothing but electromagnetic waves. And that one our visible light, which is the FZR's visible region. That is electric. It follows the inverse square law. Microwaves will follow. The radiations are following inverse square law. They can travel through vacuum also, whereas sound is not travel in vacuum. So here all bodies above 0 Kelvin, above means hot bodies, colder bodies will emit electromagnetic waves. Okay, now your answer is about the direct transmission, that is about the radiation. Okay, next one, the fourth one. A graph shows black body radiation curve at different temperature. According to Stefan Boltzmann law, the total power radiated per unit area is proportional to. So, according to the Boltzmann, Stephen Boltzmann constant, I can bulge the figure. So here some figures are missing. Okay, this is about the wavelength versus temperature. As we have a condition, wavelength is inversely proportional to temperature. That's about here. According to the condition, the total power radiated per unit area is proportional to the T for sigma T to the power. See, this is about the Stephen Boltzmann equation. You can take that one, A equal to sigma T to the power of 4. Hot bodies radiate much more energy. A star at twice the temperature radiates 16 times more power. So here, according to Stephen Boltzmann, emitted energy radiation is proportional to fourth power of the temperature. So your answer is about the T4. Coming to question number 5. Okay, I will go quickly, don't worry. Which material property is being demonstrated in the bimetallic strip experiment? So here you know very well this is about the bimetallic strip. Bimetallic strips I can bold here. See, there are two different materials we'll have in the bimetallic strip, and the two different materials will have two different expand character. Two different metals, they have different expanding character upon heating. So that is based on the thermal expansion. Different metal expand at different rates. So that aluminum is expansion is greater than to the steel. The strip bend toward the metal with a lower coefficient value. So that application. So bimetal thermal expansion principle is involved in thermostat, bimetallic strips and thermometers, fire alarms, linear expansions conditions, like we have these devices. So thermal expansion phenomena is used in thermostat. Metal thermostat means just like electrical devices, and bimetallic strips just like uh, it is made by two different metals which are having two different uh, expansion character. So that is our thermometer. These are nothing but the thermal expansion, different linear expansion coefficients. So based on that one, the bimetallic strip is working. And next one, sixth one, is about the calorimeter setup is shown primarily used to measure. Why this calorie? Calorimeter means what? Calorimeter is the branch of science which is dealing about the heat. It is dealing about heat. Now the setup is, we see here the container, there is thermometer, and in the container some material is there, and now this we simply consider this setup. It clearly illustrate that one specific heat capacity. So what is meant by specific heat capacity? So here calorimeters consist of water. Heat loss by the heat loss is equal to heat gain. This is about the calorimetry principle. Just like you can imagine that one, when you want to remove the layer of the egg, the hot layer will drop into cold water. After some time, this cold water will gain egg hotness, and egg will receive coldness from the cold water. Like that, they will come to the fetch condition, and that is about the principle of the calorimetry. Now here question is that one specific heat. Specific heat is nothing but the amount of heat required to rise 1 degree Celsius. So here 1 kg means 1 Kelvin. Similarly, if you are taking 1 gram means, and that will be 1 degree Celsius. So you can see, and here it is 4200 joule kilograms. But here if you go for the here grams, here it is degree Celsius, then it is 4.2. The value will be 4.2 calorie, 4.2 calorie gram degree Celsius will come here if you are taking gram and degree Celsius. Okay. Now question number 7. Okay, I am going quickly, don't worry. And coming to question number 7, in the phase change diagram, temperature remain constant during melting or boiling because heat supplied is used for. So when phase change is occur, temperature remain constant during the boiling and melting because the heat is supplied is what is the use of the heat what we supplied. So here the heat what we supplied here, that is changing potential energy, and that will be latent heat, and it will be used to break molecular bonds during the phase change. During the phase change, temperature is constant. You have to remember this concept. During the phase, see, solid is changed to the liquid. Like chocolate is changed to upon heating, it is changed to liquid form. Here the temperature is remain constant. There is no change in the temperature. Latent heat of fusion. What is latent heat of fusion? Ice is changed to water. Ice, the solid form of ice is changed to water, and this is about the fusion. Then water is changed to vapor, and that is called as latent vaporization. Latent heat of vaporization. So that you have to remember. So here latent heat of fusion, that is about in kilojoule, 334 kilojoules, and latent heat of vaporization, water to steam, that is about 2260 kilojoule per kg. 80 and 540 you can take. Here it is 80 and here it is about the 540 in other values. Okay, here a good observer of radiation is also a good emitter. Good observer is a good emitter. You can go for this. It's not a conductor of electricity insulator. So according to Kirchhoff law, the thermal equilibrium, according to thermal equilibrium, absorptivity is equal to emissivity. How much observed and same will be emitted. Black bodies will do the same thing. Their absorptive power or absorptivity will be equal to 1, which are nothing but they are perfectly emitter. Polished surfaces are poor absorber and emitters. Polished surfaces. Coming to question number 9, the SI unit of thermal conductivity. So thermal conductivity SI units: A joule per kg Kelvin, watt per meter Kelvin, joule per kg, Cali from gram degree Celsius. So your answer is about thermal conductivity, that is about the watt per meter Kelvin. Watt per meter Kelvin. So that is copper 400 watt per meter Kelvin is a good conductor, and what air wool will have less value. Question number 10. Which of the following has the highest specific heat capacity among the substances? Mercury, water, copper, iron. So the answer is highest specific heat out of these all, that's about the water, and which has high specific heat of water, moderate climate. So high specific means moderate climate. Coastal areas have milder temperature and helps in body temperature regulation. It takes more heat to rise water temperature. So here specific heat of water is how much? 4100. That means 4200 joule kilogram kg. Coming to question number 11, solids heat is mainly transferred. In solid, the heat is mainly transferred by the heat transfer method is what? That is about the conduction. What is that one? Conduction. And that is about vibration and collision of the particles or free electrons. Vibration and collision of particles or electrons. So that are helpful in transfer of heat in solid, which we consider as conduction. Coming to question number, that's about 12th. So that is the anomalous expansion of water occurs between where to where, that 0 degrees to 4 degrees Celsius. 0 degrees to 4 degrees Celsius, that is the density of water is maximum. So it is occur at. So water contract means what? Sink. Water contracts on heating from 0 degrees to 4 degrees Celsius. Then expand. After contracting, it is expanding. This causes to float and protect aquatic life in winter. So lakes freeze from top. So the aquatic animals like fishes will live inside the water because of this thick layer of ice formation. Coming to question number 13, the black body is defined as a body that reflect all radiation, absorb all incident radiations, transmit all radiations, emits only visible light. So your answer is about observe all radiations and emit with the same. Ideal black body is a theoretical concept, no practical. So no practical concept. It is only theoretical concept. We cannot prove in ideal manner, a practical manner. It is only theoretical one. So here that is about the how much it is observed, the same amount will be it is emitted. Come to question number 14. The coefficient of linear expansion, that's about alpha, for a rod is related to the coefficient of the superficial expansion. So as I discuss here, alpha, beta 2 and gamma 3. So here superficial means what? Aerial. So that is about it is beta is nothing but 2 times of alpha. Gamma is nothing but 3 times of alpha. So you have to remember this concept. Coming to question number 15. In the conduction rod with a conduction rod diagram with a temperature gradient, the rate of heat flow is proportional to. So that is only for the length. That's okay. Question number sorry that's about the in the conduction there is some. Okay, that's answer is about sorry options A is missing. That is related to the Q by T is about the conduction rate. That is about the rate increases larger area, higher the temperature, better conductor and shorter length. So here wavelength is inversely proportional temperature. So now here that we can say that one T by L, that is about the length concept. Coming to question number 16, why do we feel warm standing near a fire even without direct contact or air movement? So here during the winter season you may experience this condition. This is about the flame and you are standing here and this flame will be touched to you. You will get a warm feel condition even though there is no direct contact. That means this heat radiation it directly touch your sense of body. You feel warm nature and that is warm condition and that is we called as infrared rays travel, which we called as radiation. So infrared radiation is felt as heat. Coming to question number 17, latent heat of vaporization is what? So here heat required to change liquid to vapor at constant temperature. See the condition you have to remember, that is about the constant temperature, no change occur in temperature, the constant temperature. What is the liquid change to vapor form, that we call latent heat of vaporization. So coming to next one, that's the question number 18. In winter, why are woolen clothes warm? So they conduct heat better, they trap still air which is bad conductor of heat, they expand significantly. So here the answer is that in winter woolen clothes are warm because they trap still air which is bad conductor of heat. They are trapping air. Air is a poor conductor, multi-layered trap air, reducing heat loss from the body. So that's the reason we are using sweaters, we are using blanket during the winter season to protect our body from colder, to fetch our body in warm condition. And question number 19. A figure of black body radiation shows that as the temperature increases, the peak of wavelength. So here, just we discuss here. When temperature increases, the peak half wavelength decreases from the figure of black body. So here hard objects appear bluish, that means short wavelength, and that is the reason we understood that one. Temperature is opposite to the wavelength. That means inversely proportional. For the question number 20, for the same mass and same heat supplied, the rise in temperature is the minimum for what? See, as we discussed, specific heat is highest for the water, so that is the reason we understood that one from the following: copper not, iron not, alcohol also is not answered. That is about the copper is low specific heat, iron and alcohol also having low specific heat, but what is highest specific heat? So that it has the rise minimum temperature. Coming to next question, that's about the 21st one. Convection cannot occur. Where it is cannot occur? Okay, sorry, option B is missing, don't worry. That is liquids and gases. B, gases only. C, vacuum. D, solids. So here, convection is required fluids. So that means convection is happening, that is in, cannot happening in vacuum. Convection required fluids materials like gases and liquids. Coming to question number 22. The real life the real life application of bimetallic strip. So here bimetallic strip we have to use two different metals. Those will have different expansion coefficient value. So their real applications of bimetallic strip is about the thermostat, fire alarm, electric iron. These are about the not only that one, some IoT, Internet of Things also we are presently seeing. Their works on the concept of the bimetallic strip character. Coming to question number 23rd. Bending due to differential express. Sorry, that is, let I am talking about the question number 22 and the explanation also given. That is about the calorimeter is the device which is used to measure the heat. To solar cooker which take the sun radiation and to cook the food, just like the electric crystal. And coming to the bending due to the differential expansion breaks or makes electrical contact. Okay, here this is about how the bimetal strip is bending upon receiving the heat. Okay, question number 23rd. If the length of a rod is increased by 3 on heating, that is increased by on heating, the fractional change as given by F by T, or what is linear expand. Okay, sorry, just be. I will have to make a change in the question. If the length of the rod increases by delta L, sorry, we should consider this is about change of length, and the fractional change, that is delta L by L, is given by L by T. Here is what X. Okay, here the question is about the, sorry, indirectly asking that one. There is change in the length, that is about the delta L, and the change is proportional to the original length, and the change is proportional to the applied temperature. When we combine this, delta L is proportional to L into delta T. When you remove this proportionality, you will get one symbol, that is about the alpha, which is nothing but coefficient of linear expansion. They are asking this one only. So that is about the alpha is nothing but coefficient of linear expansion. Question number 24. In the convection current diagram of boiling water, warmer fluid rises because. Similar question we saw also. So that's about warmer. Just like you saw second, I think second or third question. That's about the low dense characters. That's the reason they are rises. Density decreases with the temperature. So when we have dense temperature, density decreases with temperature, buoyancy causes rising. So your answer is that is about the less dense due to thermal expansion. Because of thermal expansion, there is occur less dense. Coming to 25th question, which statement is correct about the thermal properties? So here, all metals have the same thermal conductivity. Good thermal conductors are generally good observer and emit of radiations as well. So they are taking how much they are receiving, the same will be emitted, and this is the basic quality of the thermal properties of materials. Metals have high conductivity and also high emissivity. When surfaces are rough or blackened, radiation needs no medium. So without a medium, the radiation can be pass. The phenomenon we can observe. Thank you.